Hi everyone. In this video we're going to be looking at rearranging the speed or velocity equation. This is the equation here on the screen. You've seen it before. You know that V stands for speed or velocity, S stands for distance or displacement, and T stands for time. Now this is a great equation. If you're given the distance and the time, you can calculate the speed from it. If you're given the displacement and the time, you can calculate the velocity from it. But it's not a very good equation if you're trying to figure out how far something traveled, or if you're trying to figure out how long it took for something to travel. So you'd need other versions of this equation to be able to do that. So we have the S equals VT version of this equation, and we have the T equals S over V version of this equation. These three equations are all the same equation. They've just been rearranged. And it's good if you can figure out how to rearrange them yourself. Now, for a lot of us, the triangle that you see here will be quite familiar, and it'd be a helpful way for us remembering how to put together the speed equation. You might have seen this before in your maths classes, and you know that if you place your finger over the letter V, then that would tell you that whatever's left over is the rest of the equation. So you've got V equals S over T. Alternatively, you might put your finger over the letter S, and then that tells you that S equals VT. Or alternatively, you might put your finger over the letter T, and that helps you to remember that T equals S over V. And this is a great method for figuring out which version of the speed equation you want to use in a calculation. It works really well. But in physics, we have a lot more equations than just this one equation. We have the acceleration equation, we have the force equation, we have the weight equation, and we're going to be doing all of those equations this year in year 10. So you can't rely on this triangle, this particular triangle, for all of those. So it's good if you can learn how to rearrange them yourself. However, this equation is fantastic for speed and velocity equations. I know that there are plenty of students who when they go to do a topic test, they'll go and write this equation in the top left-hand side of their topic test. They'll just to give themselves a reminder, SVT. And they'll just put that up there at the start of the test. And that's great. That's a great strategy to use to try and answer questions. Say, oh, how fast can Jodie run if she covers 60 meters? Or there we go, I know she's going 60 meters in 12 seconds. I look at my equation and I cover up the V and I say, okay, fantastic. So now I know that V equals S over T, and I just continue on with the equation from there. We end up with 5 meters per second. And then, you might then look at the same little triangle up there to help you remember, all right, how long will it take Eddie to run 200 meters? To run 200 meters, if he can sprint, not spring, at 8 meters per second. So how much time will it take? And then you cover up, in this particular example, how long, the time, you cover up the T part of your triangle, and then you say, okay, well, T equals S on V, and you go to say, right, okay, T equals S on V, which equals 200 meters over 8, which equals 25 seconds. And you can answer your question that way. Don't forget, of course, to always list your givens, which I haven't done here. S equals 60 meters, ... You know what you should be doing there. Okay, so that's a great strategy if all you're dealing with is the speed equation. Then in that situation, you can definitely just put the equation up here, SVT, and then refer to it as you need to during all the questions. That's great. But what if you don't have that triangle? It's important that you're able to understand how to rearrange the equation, because you'll need to know how to rearrange other equations when the time comes. So some tips for rearranging equations. These are good skills to have, and we're going to use these tips with the speed equation just briefly, and then you'll be able to apply them later on to the acceleration equation or to the force equation. The first tip is the power of the equal sign. Now you remember, in any sort of equation that you might have, V equals S over T, what you have on the left-hand side is what you have on the right-hand side because of the equal sign. And that will always be the case provided whatever you do to the left, you also do to the right. So say for example, I wanted to get t on the left-hand side of the equation. Well, what I could do, I could say, right, I will multiply the right-hand side of the equation by t, and that's okay, provided I multiply the left-hand side of the equation by t. And then if I do that and I follow it down, well, t times v is vt, and s over t times t is st over t. And of course, I'm sure you realize that t over t cancels out, because as you'll see in my next tip for rearranging equations, anything divided by itself equals 1. So anything divided by itself equals 1. 8 divided by 8 equals 1. 222 divided by 222 equals 1. Apples divided by apples equals 1. This is a really good way to remove a quantity from one side of the equation if you're trying to get rid of it. So we might have there what we had in the previous slide, Vt equals St over t. Well, t divided by t equals 1. So we end up with Vt equals S, and then if we just swap sides, S equals Vt, which you'll remember is one of our equations. So we should try an example. Here we have a question, and we see it's asking how long will it take Eddie to run 200 meters if he can sprint at 8 meters per second. That's sprint, not spring this time. How long? So it's time that we're looking for. We go to list our givens, and we know that his distance that he's traveling is 200 meters. We know that the speed he's moving at is equal to 8 meters per second. And it's time that we don't know. Time's the thing that we want. Now suppose that we have at our disposal the speed equation. We say, okay, V equals S over T. This is a great equation for figuring out the speed of something, but it doesn't help us figure out the time of something. So we need to rearrange this equation so that the t is by itself on the left-hand side. So one way to get the t on the left-hand side is simply to just say, well, let's multiply both sides by t. Then we've got v times t equals s on t times t. V times t, s on t times t. And that works out pretty well. That's good for us. And we have a look at that and we realize, hey, look what's happened. We've got t above and below on that fraction. So anytime you have something divided by itself, well, that becomes 1. So now we can say, right, t divided by t is 1, and that gives us then vt, which hasn't changed over here, equals s, because, the t on t becomes 1. They cancel out. They've effectively cancelled out. That's what cancelling out means. So now we've got Vt equals S. We've got the t on the left-hand side, but we want it by itself. So what we're going to do is we're going to divide both sides by the letter V. Divide both sides by the letter V. And we see now that we've got V over V on the left-hand side. And with that, we can cancel out again, because V divided by V is equal to 1. So we can now say, right, the V's cancel out over here, which leaves us with T equals S over V. So now we've got the equation that we want. Now I've got the equation that we want, T equals S over V, and I might just bring that up here to continue. And we can finally figure out the answer. S over V. The distance from our givens was 200. The speed was 8 meters per second. We get out our calculator and that's 25 seconds. Okay, we should try another example. Okay, so we should try an example. How far will Paul ride if he cycles at 11 meters a second for 6 seconds? How far will Paul ride? So as you remember, we always like to put in our givens. So we say, okay, I know that his speed is equal to 11 meters per second. I know that the time that he's doing this for is equal to 6 seconds. And what I'm trying to figure out is how far will he ride? Now, let's imagine that all I can remember, the only equation I can remember or that I'm given is the speed equation. So I say, okay, right, this is the one I remember, this is the one I'm given. But this doesn't tell me how far he can ride. I need to get the S by itself on the left-hand side to do that. So I'm going to use those tips. I'm going to try manipulating this equation, changing it around. So the first thing I'm going to do is I'm going to try and get rid of the t. So I'm going to multiply both sides by t. That's what I'm going to do first. I'm going to say, right, this side is going to be times by t, and this side is going to be times by t. And then when I do that, and I follow it down to the next line, I can say, right, okay, actually, that was just for illustration purposes. So I multiply both sides by t. So I say, right, v times by t equals s times by t over t. And then I realize that vt equals st over t. And you've got the t here divided by itself, t divided by t. And of course, anytime you have something divided by itself, that becomes 1. So now you can say vt equals s. Swap that around, s equals vt, and we've got 11 times 6, and that tells us that the distance he's traveled is 66 meters.